good afternoon, everyone. Thank you for coming to my talk. My name is Wanyun Shao. I go by Abby, in case that's easier for you to call me. And I am a faculty member at the Department of Geography here at the University of Alabama. I'm also an affiliated researcher with Cairo and the AWI. So today I'm going to share some of my research results with you, some from the past, some ongoing, and hopefully we can learn a lot together. So my topic is flood hazards, community vulnerability, and risk decision making. I thought I would like to start with a quote by a prominent geographer, Gilbert White. So Gilbert White was one of the most respected floodplain management researchers in the 20th century. In 1943, in his now famous doctoral dissertation submitted to the University of Chicago, he wrote, "Floods are acts of God, but flood losses are largely acts of man." So please take a second to try to understand, digest what he meant by acts of man. From my understanding, what he meant by acts of man are human decisions on where we build our cities, where we build our houses, and how we build our houses, and what kind of actions, or more accurately, inactions we take to mitigate potential risks posed by flooding. So, with that in mind, over the past several years, I have studied public risk perceptions of hurricane intensity, and public perceptions of flood hazards, and public perceptions of flood and drought in a comparative framework. And last but not least, public perceptions of sea level rise. All these hazards are related to water water-related hazards. In addition to understanding what shapes public risk perceptions of these various water-related hazards, I have also, along with my co-authors, tried to understand what are the drivers and factors shaping individuals' decisions to mitigate flood risks. For instance, we published this paper in Water Research several years ago. We try to understand what drives people to purchase flood insurance when they are not required to do so. And in addition, we have also tried to understand what factors influence people's decisions to support local flood adaptation policies. And more recently, we try to understand whether someone with flood insurance is more likely to adopt a whole suite of flood mitigation measures or not. The argument is, if someone has flood insurance already, moral hazards indeed predicts that they feel safe. They don't need to do other things to seek extra protection. Or a different argument can be made. When someone has flood insurance, that indicates that this person is well aware of flood risks they are facing. Therefore, they are driven, they are motivated to adopt other flood mitigation measures. So far, all these studies I have briefly described are focused on the individual level, individual risk perceptions, individual behaviors. But we know that all of us here are flood experts, researchers. We know that when a flood event occurs, the whole community, an entire neighborhood can be affected. So beyond the individual level, we should also look at the community level. What the community do, what kind of characteristics can make a community particularly prone to flood losses. So I, along with my collaborators, have tried to assess community vulnerability to floods and hurricanes, again, along the Gulf Coast area. So using GIS tools and using GIS tools, we assess the social vulnerability. And in addition to social vulnerability, we combine another layer of geographic information, namely exposure to hurricane and flood hazards over the past 100 years. So the end result is that we combine them in a bivariate map. So this map shows that a geographic variation, geospatial pattern of community vulnerability to hurricane wind hazard along the Gulf Coast, with red color indicating a heightened level, elevated level of both social vulnerability and heightened exposure to wind hazard. A similar approach was taken to map the community vulnerability to storm surge. Okay, so those are my past research. Moving forward, what we should do. As I indicated in the title of my presentation today, the three pillars of my research are hazards, vulnerability, and risk decision making. First of all, let's look at flood hazards. What we can do in terms of flood hazards. A lot of researchers here are focused on the physical dimension of flood hazards. What we can do to characterize the flood hazard and what we can do to predict flood hazards for the future. So in that front, I have been making some effort with my PhD students and some collaborators at AWI and Cairo. So in the ongoing project, we are trying to map flood susceptibility in the city of New Orleans. We know that New Orleans has a long history with the flood hazards, and New Orleans as a city is particularly prone to water-related hazards. So with a flood inventory map on the left and 9 crucial flood conditioning factors, after we use random forest algorithm, we mapped the flood susceptibility in the city of New Orleans. Okay, you are looking at two maps. First, I would like to draw your attention to the map on the left, which is the flood susceptibility map. Just as I described, we use the flood inventory map generated by the recent Hurricane Ida. And then we combine information from these 9 crucial flood conditioning factors. So the end result is the flood susceptibility map on the left. So there is another map on this screen, the map on the right. And this map, the map on the right, was generated by a public survey I conducted 2 years ago. And in that survey, I asked each respondent to select the points, places in the city of New Orleans they deemed to be at high risk of flooding. So hundreds of residents in New Orleans together generated this map on the right. Okay, compare these two maps. What's your major impression? The major impression is they are different. Wherever the algorithm tells us, wherever the flood susceptibility map tells us has high risk, the public does not necessarily agree. So there are gaps, spatially gaps. We also found temporal gaps in some of our research we conducted in the past in terms of sea level rise temporal gap. But here clearly there are spatial gaps. So that means just to focus on the physical dimension of flood hazards cannot give us a big picture. We have to take a more comprehensive approach. We have to also consider the social component, the social vulnerability layer of geographic information. So my second pillar, the second pillar of my research is community vulnerability. Okay, so we recently published a paper in findings, and during Hurricane Harvey, the local government was overwhelmed by a lot of requests for rescue because Hurricane Harvey was generated the biggest heavy rainfall precipitation event among all U.S. hurricanes in recent history. And the local government was overwhelmed by these requests. The organization Red Cross created a website to allow people who needed a rescue to place a pin on a digital map on internet so that rescuer would know where they were and they could be rescued. So through web scraping, we collected this unique data set. And overall, there are over 7,000 rescue requests. And the rescue requests also included other information, such as what kind of aid they needed the most. So this word cloud shows the most frequent word in their requests, water. So water is one because a large portion of the city of Houston was inundated. Water is the biggest, the most repeated word. Of course, you see some other words, old, children, and in terms of spatial pattern, the map on the left shows the rescue rate. What we did is we used the number of requests divided by the total population per each zip code. So the map was generated by that data. So clearly you can see where the rescue rate is concentrated across the city of Houston, across the Houston area. So I would like to show you a couple of the major conclusions we draw from this analysis. As expected, neighborhoods with a higher percentage of young children and people who live in poverty tend to have higher concentration of people who requested rescues, controlling for the effects of all the other factors, variables. In addition to a bunch of socio-demographic characteristics, we also included a traffic index showing what the traffic condition was during Harvey, and also inundation index in this, controlling for the effects of these factors. These socioeconomic factors emerged as significant determinants in influencing the concentration of rescue requests. So surprise, surprise. And percentage of people who speak limited English is negatively correlated with rescue requests. This is really surprising. So what does that mean? This indicates that not being able to speak English can be inhibitive during an emergency. So because they couldn't speak English, they couldn't request the rescue in a timely manner. So in another sense, it shows how important social vulnerability is in terms of determining the outcome during a disaster. So if social vulnerability is so important, then we should put more effort into understanding the geographic pattern of social vulnerability. Not only the geographic pattern, but how about the temporal pattern? How about how the social vulnerability can change over time? With that in mind, we conducted another study. This paper is under review right now. We call the spatial temporal patterns of community vulnerability in Mobile Bay from 2000 to 2020. Very quickly, I have several studies to share with you guys, just very quickly. So in this study, we did not only focus on one particular year. Instead, we collected data from the year 2000, the year 2010, and the year 2020. So after we collected the data, we used the PCA, principal component analysis, to reduce the data dimension, and then we created our social vulnerability index as the literature informed us to do so. So here is the map. Here is a series of maps consisting of 3 maps from 2000, 2010, and 2020. So overall, you can see a pattern emerged. What's that pattern? The pattern is that over time, over the period of 20 years, social vulnerability has expanded outside, beyond the city limits of Mobile. So over time, it has expanded. In order to validate the observation we made with our eyeballs, we used the hotspot analysis and the cluster analysis. Both analysis results confirm the observation we have made earlier. So the area with the heightened social vulnerability has extended over the period of 20 years. Okay, so now let's talk about another thing. We talked about exposure to flood hazards. It's important. And as we all know that's why a lot of you are doing modeling, trying to predict which places tend to be the most prone to flood hazards. We also know that social vulnerability is also important. But we know that the world is complex. They do not exist in isolation from each other. They interact with one another in real world. So with that in mind, I would suggest that we assess flood risk in a more comprehensive manner, which is to combine exposure to flood hazards multiplied by social vulnerability. So in an ongoing project, my PhD students and I are trying to do what I just suggested. So first, we created through a random forest algorithm, we created a flood susceptibility map in Harris County, where Houston is, in Harris County, Texas. And on the left, we created another layer of geographic information, social vulnerability map. And we combined them, we created this end outcome, so flood risk zones. So this layer of geographic information combines both flood susceptibility and social vulnerability. Okay, so most of my research up to date has been focused on risk decision making. I thought it would be fair for me to spend some time talking about social risk decision making. So that's the third pillar of my research. As scientists and engineers, oftentimes we are confronted with this question: what's the meaning of our research? What can we do to help society? Is our work really impactful? I'm here to tell you, yes, your work is very impactful. Okay, I'm going to use some studies to illustrate this point. So a few years ago, I conducted this research I briefly described earlier at the beginning of this presentation. We try to understand what drives people to purchase flood insurance when they are not required to do so. So it's a voluntary flood insurance purchase behavior. And one of the major conclusions we drew from the data analysis is that FEMA flood maps have been effective in conveying local flood risks to coastal residents and correspondingly influencing their decisions to voluntarily seek flood insurance in the U.S. Gulf Coast. So flood maps, despite its inaccuracy, flaws, they are a powerful flood risk communication tool. And all of you, if not, most of you, if not all of you here, are doing that work, trying to make sure flood maps are more accurate. If flood maps are so powerful, then we should try our best to make those maps as accurate as possible. So that's one of the conclusions. And more recently, we published another paper, and we tried to test a hypothesis whether someone with flood insurance is more likely or less likely to adopt a whole suite of flood mitigation measures. The conclusion is the former. Someone with flood insurance is more likely to adopt other flood mitigation measures. What does that mean? That means the flood risk informed by FEMA's flood maps not only provides the compulsory basis for flood insurance purchase, but also determines individuals' overall support for flood mitigation. And the inference is flood map inaccuracy can immensely mislead individuals' overall risk mitigation decisions. So it's critical, it's crucial, it's essential. So we all need to make efforts to make flood maps as accurately as possible. Okay, here is another ongoing project I and my co-authors are doing. How flood maps impact residents' flood risk mitigation strategies. So far, those results I have shared with you, at least in terms of risk decision making, are based on survey data. In economics, there are two types of preferences. One type is called stated preference, and the second is revealed preference. So survey research has its own limitation. Just because the respondents tells me they would like to do something, that doesn't mean they will do that thing. Their behavior will be the same as what they tell people. So in this study, we try to overcome the limitation posed by traditional survey research. We try to reveal the preference to examine how flood maps can influence residents' flood risk mitigation strategies. Back to the data I mentioned earlier, the rescue requests during Hurricane Harvey. Here is a map showing the number of rescue requests during Hurricane Harvey. And we also included information about flood zone, once again designated by FEMA flood zones. And we were trying to understand something. So here I would like to introduce a new concept, maybe new to you guys, engineers here. It's called natural experiment. And natural experiment rose to fame a couple of years ago because 3 economists won Nobel Prize in economics because of their contribution to causal inference. Natural experiment is not like any experiments we conduct in a lab environment. So there is no artificial control, arbitrary control, and we do it sometimes in retrospect. So I'm just gonna briefly describe what the natural experiment is in this case. So what we are interested in is, assuming everything holds equal, the neighborhood outside the flood zone and inside the flood zone, close to the flood boundary, holds equal. They share more or less the same socio-demographic, economic characteristics, and they are both two neighborhoods. They are both inundated during Hurricane Harvey. If one neighborhood inside the flood zone have higher or lower rescue requests than the neighborhood outside the flood zone, that means something, right? Does that make sense? Should I move on? Any questions about the natural experiment? So we use the regression with the discontinuity design, and we did find that when everything holds equal, the neighborhood outside the flood zone, right outside the flood zone, would have a higher, statistically significant higher rescue requests than the neighborhood inside the flood zone. Okay, think about it again. Everything holds equal. So these two neighborhoods, everything, they were both inundated by flood. And they share the same socioeconomic, demographic characteristics. In terms of vulnerability, they are the same. They have the same social vulnerability. They also have the same exposure to flood. However, the neighborhood right outside the flood zone have a higher rescue requests rate compared to the neighborhood inside the flood zone. So I would be bold to imply that the flood zone designation informs people of the risk, heightened risk, flood risk they are at. Therefore, they are more likely to take flood mitigation measures. Therefore, they have lower rescue requests during Hurricane Harvey. Do I make sense here? Okay, I see a few confused faces, but I will be happy to answer any question. This is an ongoing project. We are trying to write the manuscript right now. So it's I think that means something, right? Flood zone designation, despite its arbitrariness and despite its flaws, they serve as a powerful flood risk communication tool. Okay, so I'm running out of my time, and before I wrap up, I would like to share my research agenda, future research agenda with all of you. So, as I said, the 3 pillars of my research are hazards, vulnerability, and risk decision making. And I would make the argument that the behavioral dimension is critical in order to build community resilience and mitigate any risks posed by natural hazards. That's why I put risk mitigation here. And here is, I would call, the cycle of disasters. So when disaster happens, and all of a sudden everybody who's impacted by the disaster would have a super heightened risk perception. Oh, I've been flooded. I want to buy flood insurance right now to protect myself. A few years went by and their awareness, their heightened risk perception would decrease, would decay, then leads to reduce the risk perception. And because now they don't perceive as high risk of flooding as before, they start to drop their flood insurance. They start not to pay attention to those potential risks. Then increased exposure hazards that put themselves at a higher risk. Then disaster happen again. So what we need to do as researchers, as scientists, as engineers, as policymakers, as planners, is to intervene at the right moment, at the right place, trying to educate them, communicate with them about the real risks they are facing so that this link won't be so strong. So intervene somewhere. That's the research agenda. That's my future research agenda. Since I quoted Gilbert White at the beginning of my presentation, I would like to end my presentation by quoting him again. He wrote, "It has become common in scientific as well as popular literature to consider floods as great natural adversaries which man seeks persistently to overpower. This simple and prevailing view neglects in large measure the possible feasibility of other forms of adjustment." So I would argue that risk decision making, what decisions we make now, can largely determine how much loss we will suffer from in the future. With that, I would like to thank all the funding agencies who support my research, and thank you all for your attention. I will be happy to answer any questions you might have.
For the sake of time and because